Welcome back. One more thing to review this week is the program processing, the translation or interpretation of the source code to be executed by the computer. As we know, high-level languages are not understood by the computer, thus some need to be done. Let's see. Option number 1. Some languages are interpreted. That means they are translated in real time, line by line. That is the case of the lesson prologue version that we will use in this course. This model has some advantage. One of those, you do not need to compile the program before execute the program, so that makes the development quick, because basically you're writing one line and executing that line at the same time. This makes the debugging process simple. Basically you are debugging line by line the program at the same time that you are creating it. The disadvantage of this model is the slow execution, because before execution the translation process is done and then you need more memory space. Usually when you are using an interpreter or a virtual machine, that means your program is going to need more memory when you try to run it. Other languages are compiled. Compilation is the process to translate a language to another language, usually a high-level language to a low-level language. When the goal is to translate a high-level language to a machine language, usually that is done in 3 steps. First, the compilation process translates the source code to assembly language. Then the assembly language is translated to machine language. And finally, if there were several files involved or external libraries needed, a linking process puts everything in one piece. A program that is compiled runs faster than a program that is interpreted. So compilation allows faster execution than interpreters. And when you have a piece of software formatted by several files, it's better to compile them than try to run it using a virtual machine or interpreter. The disadvantage of compilations are what we previously mentioned as advantage of interpretation. C and C++ follow this model. We're going to be using a compiler for them. Finally, a third option is an hybrid model, where both compilation and interpretation are used, or a 2-step compilation is implemented. Java is an example of a language that uses compilation plus interpretation. The compiler of Java translates the source code to bytecode. Bytecode is an example of intermediate code. Then you can execute that program in any computer that have a virtual machine of Java installed. On the other hand, Microsoft.NET is an example for languages that use compilation plus compilation. The .NET platform provides a compiler for each of its languages and basically translate the language to an intermediate language called Microsoft Intermediate Language. And then a second compiler is able to translate that intermediate code to matching code in a particular platform. The main advantage of using intermediate code is portability. You can compile one and use the intermediate code in different platforms. The disadvantage of this model are the same that we described before. Those are our options for program processing. Thank you for listening and have a nice day.